Junaid has his PhD and postdoc research in wireless communication at the University of London and Queen University Belfast. He has 27 international issued patents related to various aspects of wireless telecommunication in the US, UK, and China. And he's created the microwave and the mmW antenna business of an international company, Rosenberg. He's the general director of the company. So the floor is yours, Junaid. We can see your screen, so please go ahead.
Okay, thank you very much. I hope you can see my screen.
Thank you very much for your time and your efforts. Thanks.
Okay, first of all, thank you very much for having me here. Some of you may not be aware of Curvalux, so I think I will just say a few sentences about Curvalux. Curvalux is an international company. Our design headquarters is in Sheffield in UK, and we have a global presence. We are mainly working for the whole system and a solution development for fixed wireless access, and also some of the product could be used for backhaul also. So today I'm going to talk about the green wireless network backhaul and fixed wireless access. I will talk something very general about the new trends, that why there is a need to think about this topic. I will also, I've been part of the TM4 committee at ETSI for many years. So I will also share some of my earlier experience, and I will share some of the regulatory requirements also from the sustainability point of view with respect to the ETSI. And then in the end, I will talk about some of our solutions, some of our product, what we are doing it. So I think the main thing is over here, the internet, we're talking about the digital connectivity, and the digital connectivity, the one of the, of course, application is the internet, which we are talking about 4G, 5G, and 6G. And this digital connectivity could be between human being to human beings, or between human to machines, or machine to machine. There was a time when I remember this digital connectivity was considered as a status symbol, but now it is no more a status symbol, but it has become the indispensable part of our daily life. And it is not just a privilege, it is a boundless source of inspiration. And this is basically give us the inspiration for the everydays, our work. And I think this is the thing which is not limited to a specific community or a specific regions or a specific color. I think it has become the right of everyone to have a digital connectivity now, because it allows the breaking of the boundaries, bridge the gap, and gap not just between the human beings, but of course the gap between the economies, between the cultures. So from that point of view, I'm trying to emphasize that how important the digital connectivity is becoming now. And it's not only the issue of the urban areas or the sophisticated systems, but I think it has become the need of everybody now. But the problem here is that nearly half of the world population still does not have the reliable internet connections or internet access. What does it mean? It means basically they cannot work remotely, and the COVID has already proven that. The other thing is there is a lack of remote education in those areas which don't have the reliable internet connectivity or the digital connectivities. The access of the telehealth, this is we have already seen in last few years. Apart from this, there is, of course, the awareness is also very important for decision making for anybody, and is the right of everyone who lives on this globe to have that decision making power. Online social services are not available, and we know that some countries the social services are very important, and we need to be, of course, be in touch. And I think one of the biggest problem, which is the social exclusions, the recent COVID has already proven that the digital connectivity, availability of the digital connectivities, I think the reliable availability of the digital connectivity to all human beings is becoming more of a necessity to avoid any social exclusions. So apart from this, so this is one dimension of the problem, that people don't have the connectivity, and we are talking about 5G, 6G, and of course so on. But let's look at the facts of the life. The facts of the life is still there are about 700 million people who do not have the basic electrical power. I know last decades, a lot of work has been done in many countries, but still if you move around in some of the continent, they don't have electricity to light the bulb there. And definitely this is one of the biggest constraints. The second issue is, of course, those countries which have the electrical power, look at the bills, electricity bills, how they are rising. And if they are rising for your household, just imagine for the telecom networks where the main operating cost, about 20 to 40% is based on the energy cost, how much it is increasing. So on one side, there's a problem of availability, and on the other side, there's a problem of the cost. But there's a third problem also, and that third problem is that today also, about 36% of the electricity is produced from the coal, and I think about 26 or 27% from the gas. Now, this causes another problem, and that is basically the CO2 emissions. And that, if you just look at it, from the different segments are, of course, creating that issue. It's not just the information communication technology, but in one of the research which has been published, just from the information communication technology, about 700 million tons of carbon dioxide emission annually, which is about 1.4% of the global contribution and the output. And out of this information communication technology sector, nearly about 220 million tons carbon dioxide is coming from basically the infrastructure, from the mobile infrastructures, and with those development and those things. And similar issues we can see even in some countries, like in China and other countries, but it's not only a regional problem, it's a global problems. So now we have got few problems on front of us. Number one, the lack of connectivity, the digital divide. Number second, okay, we should reduce the digital divide, but in order to reduce the digital divide, there are many countries which do not have the basic electrical power. So definitely the system should be such that, first of all, they should be affordable and available to all communities. Second, they should be available to those regions also which do not have the electrical power sources, which means thinking more of the renewable energy solutions. The third problem is the cost of the electricity, which means the system should be designed, whether for 5G or 6G, which should be energy efficient. So they should use less energy, less operating expenses. And the next problem is the environment pollution and all that things. And the CO2 emission is directly related to the power generations and all those things, which we are doing it. Different studies have been done. So another thing is the solution need to be power efficient. Now, all these things are leading to basically one type of a solution, and that solution is something different than what we have been doing in the past. So whenever we are developing any product or any solution, whether it is coming from a university or it is coming from the industry, we were keeping 3 KPIs in our all projects. Generally, one is the performance. What's the performance you want? We should be able to achieve it. Have we achieved it or not? I'm talking the real life issues now, not just the R&D research lab, but a product and a solution going to the market. So I'm talking about something from concept to the customer and from customer to the end of the life. This is the whole eco cycle which I'm talking about here. So one KPI, we talk about the performance, good, bad, cost, achieved or not achieved, the schedule, time to the market. These are the 3 KPIs which were generally kept in all product development cycles. But the problem which I've highlighted, now the focus is changing. And now we are talking about the 6G and all those things, where we see in 6G, we are talking about not just the performance, cost, and schedule, but we are talking more than this. There's a lot of work is going on the artificial intelligence, integrated sensing, remote and communication, but one more KPI, one more matrix has been added, and that is the green technology. And once we are saying even with the integrated sensing and communication, so we are talking about the 2 functions now. So we are increasing the functionality. One is the sensing and second is the communication. Definitely the power requirement, if you go from the old concept, it will increase. So in order to overcome that things, a green technology has also been added. So what does it mean to us? What is our responsibility to those who are developing a product or who are doing any design work, whether in a university or in industry or in public sectors, that we need to add one more KPI. in addition to the performance, cost, and schedule, and that is the sustainability. That is our solution sustainable or not? Now, as we always say that nearly the 80% of the cost of any product is decided during the design phase. The same concept can be applied that 80% ecological impact is also locked in the design phase. And what is our impact? What is our objective? Our objective is that whatsoever we are designing, whatsoever we are manufacturing, whatsoever we are using today should not have a negative impact on our future generations. This is what is I'm talking about a sustainable solution, not just reducing the power supplies, consumption and those things. So what does it mean? That the solutions which we are designing or the solutions on which we are working anywhere, it should have a positive environmental impact, socially just, and economically viable eco-design. So these are the 4 key yardstick which we should keep in every project, in every design activities or any manufacturing activities which we are doing today in moving forward to the next level. And once we are talking about moving to the sustainable designs, what are the challenges? First, the biggest challenge is the problem of our mindset. And the mindset is the status quo, because our industry is addicted to the mass production, fast-moving disposable goods, the waste and all those things. Whereas we have seen just moving from 4G to 5G, what changes we were talking in terms of the capacities and the volume per area and connected devices. And 6G, we are talking about the use cases of robotic military actions, holographic integrated. We are talking about terahertz. We are talking about latencies in decimals. So definitely, if these are the challenges these are the target which we are trying to achieve, and we are still in that mindset that design something, go to the market as soon as possible, and with the disposable goods, definitely it is not going to solve the problem. Now, the biggest one of the variable which comes up, which we always hear a lot, energy efficiency. Energy efficiency metrics, basically efficiency, just the ratio of the output and the input, right? So we are talking about that if I have to produce that much traffic, how much electrical power will I consume in watts? Or if I have to give this much coverage, how much electrical power I need to consume? If I need to give this latency, how much electrical power I need to consume? So these are the many things which we need to keep in mind during all the design and all the development work. ETSI ETSI in its one of the document, which is 228 document, they've already defined the energy efficiency in their own terms. And they have defined the energy efficiency is the ratio of the data volume in a mobile network, in one mobile network, which using one radio technologies divided by the measured mobile network energy consumption, which means how much data volume you can create in a mobile network using how much energy consumptions. And that is what is the definition of the energy efficiency. If you keep that definition as an energy efficiency as per the ETSI regulations and the requirements, definitely it will always give us a guidelines, and it will always be one of the KPI in our all work when we are talking about any new solutions. Some people are talking in terms of just watts per megabit per second. So for example, I can create so many 5 megabit per second or 5 gigabit per second, and how many wattage of the power will I need? That is another yardstick which some of the manufacturers have started using now in defining their systems. Now, the problem is not just the designing work. We have to talk the whole philosophy here, the whole life cycle of the goods and the business models, right from the, as I said, from the concept to the end of the life, which include the manufacturing and the supply chain also. It means that we need to be more focused on the recycling, reuse of the products, more efficient use of the raw materials. And of course, there are new regulations have come in 2021 in many countries, including in UK, that is right to repair. Right to repair means that whatsoever you're designing, whatsoever you're manufacturing, you have to give more rights to the consumer so that the durability of the product can be increased. So we need to see from the all aspects, not from just from the design point of view, if you really want to move forwards. And in order to do so, for the information communication technology things, definitely we need to keep in this thing in our solutions and in our design, that whatsoever we are doing it, is it repairable, means how the design is moving forward, can the things can be detached or not, how long it can survive. And other thing is the raw material, the supply chain, which we are using, how much percentage of the raw material in this design can be recycled or reused. Upgrade could be a software-based upgrade or the hardware-based upgrade. Generally, the trend has to move forward that if software upgrade has to be done, there should be less monopoly of somebody to basically restrict someone to upgrade it. Or from the hardware point of view also, the design should be such which should be more modular, so that one module can be replaced and the product can be upgraded. And similarly for the reuse and recoverability. So all these factors need to be kept in mind, whether it can be repaired, whether it can be remanufactured, whether it can be refurbished. And in the end, we should think about how to consume the raw material which has been used in this design. So this is what ITU standards and plus the ETSI already has got a lot of documents. And if anybody is interested, definitely can contact me later on and we can talk about it, that where to look at it and from where you can get the basic guidelines and you can start including it in your design phases. Now we are talking about the wireless, the media, right? But at the same time, if you see, we all are talking about the gigabit dilemma. There are different schemes going on in different countries, like in UK, scheme is going on, the voucher scheme and all those things. But many times what happens, whenever we talk about the gigabit, we always go toward the optical fiber. And definitely optical fiber is a good choice. I'm not going to talk about here the issues and all those things. But in the end, we are trying to achieve more coverage and range, and at the same time high capacity, which are going opposite to each other's, and then less complexities. Less complexity means that if you're designing something which is qualifying, let's suppose the ETSI standard, will it qualify the FCC standard of USA? Will it qualify the ACMA standard of Australia? Will it qualify the Anatel standard of Brazil? Will it qualify the BSNL standard of India? So we need to think about those things, that how the same product can be used in different regions and different countries. And of course, from the cost should be such that it is affordable to those people who have a low income, so the connectivity in the 6G can go to those neglected areas also. Other things which we are, of course, coming up is the cyber security threats and all those things. This is itself a big, itself is a separate topic. But all these things need to be considered in our wireless communications, new product which we are developing for 5G and 6Gs. And keeping in view those things, if we see from the energy efficiency point of view, let's first look on the terrestrial networks. The terrestrial network generally, from legacy stuff, we divided into two things, access and the backhaul. Access could be the cellular, or it could be the fixed wireless access, and the backhaul could be short haul and the long haul. But just now we are seeing the heterogeneous networks and all those things where the access and the backhaul are merging together. The functionalities are merging together. That will definitely have a positive impact on the energy efficiency and those things. The functionality of the radio on the access is splitting the remote radio units and of course the baseband and all those things. So you need another connectivity with the front haul. And all these things are moving in a directions we are trying to improve the connectivities, but there are a lot of opportunities to basically improve the energy efficiency. IoT networks, a lot of activities are going on to basically detect something, then communicate it, then analyze it, make a decision and execute it. Now, all these functions need some energy at every level. So we need to be basically focused at all that different levels. Now, if you see from the ETSI point of view, the assessment of the mobile networks as a network level is just the summation of all the components. It is, if you see on my right-hand side, this equation, this is the energy consumption. It includes the base stations also. It includes the small cells also, which are the infrastructure, which is on the base station energy consumption. Backhaul, data centers is another source where a lot of energy is being consumed. The data center could be remote, data center could be basically in the near vicinity. All those components need to be added. So the summation of all these components comes when you add them, then that is called the energy efficiency of the networks. It is not just one antenna or one product. And this is what we need to keep in mind, that how to basically compute the energy efficiency of your network based on the radio access technology as per one mobile network operators. For the non-terrestrial networks, Curvalux has got the DNA of the satellite communications. So we are also in the satellite communication segments. There are, of course, a lot of activities are going on. There are some challenges, some opportunities. I think because of the time, I will not go quite a lot in this. I will just move forward, but I will just say that one of the limitation of the link budget, of course, here, and we know that the EIRP has a direct correlation with the use of the energy, right? Energy consumptions, that how many devices you are using, how many and what type of devices you are using, and what IC technology you are using, the gallium arsenide or GaN, and plus right from your baseband to the up conversion, then the beamforming, then the power amplifier and the receiving part, the low noise amplifier, all these are definitely at the payload. And for the aerial vehicles, there are two sources of the power consumption. One is the propulsion, other is the communications. And then, of course, the cooling is also very important, because if the cooling is not good, it reduces the efficiency. And of course, there is more energy consumptions, and the power of the system will not be that sufficient. And there are many opportunities also, and we are working in that areas, especially in the antenna design, beam shaping, and the phase arrays. And the other benefit of course, the unmanned aerial vehicles is you can move that thing as per the capacity requirements. But remember, in the low Earth orbit satellites, let's suppose the constellation of the satellite, there are challenges also, the base terminal, because the satellite is moving, and you need to have an antenna which can have a connectivity all the time. So it means some electromechanical or some phased array technologies, so that you're always connected with one of the satellite in the LEO constellations. Now, in keeping in view all those things, we are working in different areas. We are working in Curvalux how to increase the spectral efficiencies, different modulation scheme, the MCS factor, spatial efficiency. A lot of work is going on the antenna side. Bandwidth and higher frequencies is also, we are moving into different frequency band, higher frequency bands. And a lot of work is going on for the low side lobe level to improve the C over I and multi-band operations, and having a software-defined antennas and software-defined networks. These are the main things. We are also in the Wi-Fi areas, and plus the 5G millimeter wave frequency regions where we are working. In that case, Wi-Fi 6 to Wi-Fi 6E now, where you can use the 6 gigahertz, and then Wi-Fi 7 products, where you can do the multi-link operation. You can cascade the 6 gigahertz, and you can use a very high band channels. So all these things are moving forward. The base station connectivity, which was mostly at RF, has gone to the microwave, and the backhaul, which was in microwave, has gone to the millimeter wave, and soon on the terahertz and all those things. So there's a lot of work, and each has got its own challenges and opportunities. From the opportunities point of view, definitely the heterogeneous networks, which is another areas where you can share the resources. Low power consumption, as I mentioned earlier, selection of your component and your design strategies. Hybrid networks, which I discussed, terrestrial and non-terrestrial. Antenna technology, which is high antenna efficiency in the beam forming. This is one of our key area in which we are working. And apart from this, from the data center point of view, the power usage efficiencies, how much power is really used for the IT devices as compared to how much power is used for the other structures. So all these factors are important for the green digital networks. And one of the main activity which we are doing is going from a single beam antenna to the multi-beam antennas, which we are using the phased array antenna technology. So if you see in this slide, what we are doing it, that we are basically covering one sector instead of a one beam with the multiple beam. In this product, we are talking about the 16 beams. And in the 16 beams is or it could be the 16 beams in 8 direction, or 16 beam in 16 direction, depending upon the dual polarized and using the MIMO. Now we have done 16 beam in 8 direction and using the XPIC MIMO. This is how what we are doing it. Just assume the pipes are running narrow pipes, and we are reducing the interference, and this is the way to increase the capacity. This is the technology which we are already using, and the product is already deployed. in many countries for the phased array antenna technology for sub-6 gigahertz. We are also working in the millimeter waves. And in this way, basically, this is the product where we have got the phased array antenna technology sub-6 based on Wi-Fi 6. Now we have moved to the Wi-Fi 6E, and soon we will move to Wi-Fi 7 also. We are merging the base 5G technology with the Wi-Fi technologies, and we are coming up new systems for the millimeter wave, which is the 5G frequencies and also above with the multi-beam solution for the access point and CPEs. All these will provide connectivities, and these all are energy efficient designs. For example, here you can all run this system using a solar panel, which means those countries where the power is not available, these can be deployed because the less power consumptions, definitely the solutions will be more sustainable. And we are also working on a satellite ground terminals with our partner Freefall. As I mentioned just now, that in the LEO, the most important thing is make before break, because there are about 8 satellite or 11 satellite, depending upon the constellation, depending upon the latitude, depending on the coverage. You need to look at one satellite at a time and then move to the other satellite. The general prior art is people are using 2 parabolic antennas, and they are moving. The whole parabolic antenna is moving to track the satellite. But what we have done, this is a novel idea where the reflector is static, and we are using the 2 feeds. And the 2 feeds are moving up and down and left and right, and they are always selected one satellite in the orbit, and from one horizon to the other horizon. So it is covering the full sky. And this can provide you a very low cost and energy efficient solution, because if you are having a 2 system, power consumption about 500 watts, you can do it with one system, which means about 250 watts. So straightway power consumption, weight, cost, everything is reduced because this design. There's another product which we have developing now, which is embedded on the ground to have more zoning friendly. This is the 2 spherical reflectors, basically scanning and looking all around the sky and provide the connectivities from the low Earth orbit satellite at a remote locations, and these all can run on a solar panel. And from here, you can use the other system of the fixed wireless access and provide the connectivity to the grounds. So basically, we are working in both in the fixed wireless terrestrial and also for the ground terminals. And the main objective is here is to have a sustainable solutions with the low power consumptions and something which can provide a gigabit connectivity through wireless, because that was a dilemma that this can only be provided by optical fiber. So this is the main activities which we are following at the moments. And of course, this all work is going to in line with the sustainable solutions. And this is the main core of this company, and we are doing it. So in other words, we are just moving forward, and let's join hands with a mission of bringing the sustainable solution to our world. Thank you very much.
Thank you very much, Junaid. That was a fascinating talk. I'm sure we have many questions, but I'd like to ask you to take the questions over the chat, if that's okay.
Yes.
And just to make sure that we don't run out of time. Thank you very much for that. So please go ahead and ask the question. I have a couple of questions for you that I will post on the chat shortly.